Hello and welcome to a short video about my self-designed AM modulator. This here is it. It has just two transistors and it works really good. And now I'm give you an explanation how AM basically works and what AM is. AM, amplitude modulation, means that the signal level, the level of the signal or the voltage of the signal is changed over time. Here you can see here this is the carrier signal and here this is the modulated signal, and it changes the signal. You can see here the signal level. This is AM, and now I'm showing you how to can build a circuit that do AM modulation. AM modulation means that the two signals are multiplicated, which means not edited, they are multiplicated. Here is a bit clearer explanation what that means. Here you can see this circuit adds both signals together. If I'm looking to the signal that is on this resistor, it looks like this. You can see here this generator here is the HF generator, which is generating the HF signal, and here we have the NF signal. And here you can see the edited signal. You can see here it's going this way, but we want a modulated signal, an AM modulated signal, and for this we must take this here. We need a non-linear component with a non-linear characteristic, like a diode you can see here. Now we are also editing both signals together here, but on the characteristic of the diode you can see this here. The edited signal goes here this and goes this way, and then we have a amplitude modulated signal, not absolutely amplitude modulated but half amplitude modulated. And the second side of this signal, that it is complete, we get if we take this. This here is an LC resonance circuit, and the resonance frequency of this LC resonance circuit must have the same frequency that the AF signal, and then it is completing your signal and you get this perfect amplitude modulated signal. This is not really difficult, but yes, it's easy. Okay. And here I'm showing you now my circuit. This is the circuit diagram of my circuit, and you can see here at first, this here is the oscillator that is generating the HF signal. This oscillator, I'm doing an explanation in a later video maybe, so I'm not going to explain this now, maybe in a later video. But one important thing is, to calculate the frequency of this oscillator, you need this equation. The frequency is equals 1 by 2 times P times square root of L times C. Okay, and now here we're going to the modulator. This is the modulator. You can see here there comes the NF signal, the HF signal. Here it is edited together, and at this point it is modulated. You can see here this transistor acts like a diode, because we have here a diode with a non-linear characteristic, and here we have the LC resonance circuit, and with this we get our amplitude modulated signal. And this is the circuit that I have built. It is not really difficult, but it works really good. And here you can see the circuit. I have connected the oscilloscope to the output of the circuit on the second channel, and on the first channel I have connected my function generator, which is supplying the NF signal. And yes, that's for the thing. I'm supplied with about 10 volts, and now let's take a look to the scope. So now we're taking a look to the scope. Here I've connected my function generator to the input of my circuit. This is generating a sine wave of about 1 kHz, and here I have the scope. As I have stated before, on the first channel this here, the upper channel, I have connected directly the function generator, and on the second channel I have connected the output of my circuit. This is a 10 times probe, and this is just 1 time. So this is 10 times lower than this signal, because here we have a 10 times probe. So now I switch on the oscilloscope. Okay, there it is. Here we have the function generator. There we have the output of our circuit. So now I switch on the power supply. And you can see here the circuit is producing a HF signal. Now I'm triggering on this HF signal and zoom in a bit. Yes, here you can see it. This is our HF signal. Yes, now I zoom that out. And now I switch on the function generator. And you can see the amplitude modulation is working. Here you can see the input of my function generator. I can change the level, you can see here. And here you can see the modulated signal. You can see it's perfect modulated like this, up and down. And if I'm taking less level from the function generator, you can see here it's less modulated, and if I take it too high level, you can see this means overmodulated. So the signal is now overmodulated. In radio broadcast use, modulation factor of about 80%, maximum 80% is normal, but not more than 80%. Now I trigger to the second channel, to my HF signal, and put this up here, and now you can see how it looks like if we are looking to the HF signal, trigger to the HF signal and zoomed in. You can see here this is the signal, and here you can see this is because it goes up and down with this with our function generator frequency. If I put the frequency of my function generator down, you can see here how it moves, and if I put it more down, you can see here, now you're really good. Now it's really good to see how the modulation really works. Amplitude modulation means that the signal is changed by the input signal. Okay, good. Now put it up again like this. Okay, now I put in a square wave signal. Square wave signal looks like this, and now I put in a triangle signal. This is it looks like this, and trigger again to the first channel. You can see here this works, and this is also working. You can see here this is how sine wave, triangle and square wave, how it looks like to the modulation. So now I change the frequency that you can see here. If I change the frequency, my function generator board is a little dirty, so yes, that is for that. So, but if I change the frequency, you can see it also changes the frequency. That's for my amplitude modulation circuit. It's a really easy but useful circuit. And in a later video, as I've stated before, maybe I show you how the oscillator really works, and I'm also going to build a demodulator which is demodulating this signal. So that's it for my amplitude modulation video. I can say thanks for watching, and I hope you have enjoyed this video.